Hello, welcome to Sarasa classes. This is Dr. Sakar over here. Now, in this particular question, as we can see, it has been given to find out the major product formed in the following reaction sequence, where we have been given a alkene, which is substituted, and it has been treated with tertiary butyl hydroperoxide and with the minus DET, that is diethyl D-tartrate, and titanium isopropoxide. Now, whenever we have this minus DET, then the attack of the O to the double bond stereochemically would be from the top side. Okay, so we will be representing it with the alpha bonds. Now, in the next step, when you add NaOH, it will be taking up this particular OH. So there is a formation of a negative charge over here, which will be making a SNGP, that is substitution nucleophilic neighboring group participation is taking place over here. And consequently, we can think that this epoxide is opening up. So this particular O minus will be on the top side. This is coming from the back side. So this will be having a stereochemical representation, which is we will be using the beta bonds or the dash bonds to represent it. Now, when we have a thiol reacting with it, so obviously we can think that this H is going to be protonating this O over here. Also, this can also be protonated. So what will happen that the S will make a nucleophilic attack over here because this is less crowded and this is more crowded. So now keeping in mind over here the absolute configuration, because that will help us to choose which is these products. All right. So what we can see now is that this over here is R and this over here is going to be S. All right. Now on protonation, we are getting, so this is in the when the orientation is like this and this OH group is going to be opposite to each other. So once you write in the zigzag form, so they will come both in the alpha bonds, and hence one can even use the absolute configuration to judge whether this is R and this is S, and accordingly one can judge the product to be as 2 over here. Okay. So for the next question, here you have been given in 98, the major product formed in the following reaction sequence is. So this is again an epoxide where the pH is back and this pH is on the front. That means this H is on the front and this H over here is on the back. If you make an attack with the D and subsequently open up this ring, and then we can write the whole thing. So you can think that D is coming from the down. So we will write like this, and it opens up like a Y, where P is going to be on the back side and H is on the front side of this CC bond. All right. And accordingly, we will write the O on the top because it is now opening on the top. All right. And we will say this H is behind and this pH is on the front side. The lithium will be balancing the charge on the oxygen, which can now make a nucleophilic attack to the anhydride, which is given over here, which is acetic anhydride. So what will happen that this double bond O will open up and subsequently come back, and this will act as a leaving group. So basically we have generated a ester of acetic anhydride, all right, from the acetic anhydride, or we have undergone acetylation. All right. So now what happens when you heat this compound, what we will do, we'll bring the H syn to this ester group, and we can now think of a intramolecular elimination reaction that is taking place in pyrolytic conditions, and such esters undergo syn elimination reactions. So obviously stereochemically, the answer that we will get will be over here 2. For the next question, here we have been given TMS means trimethyl stearyl, okay, and the major product formed in the following reaction we have to find. Okay, this is a, obviously this is the C with the double bond with N having a plus charge. Now, what we can think is the lone pair donation will happen from the O to the conjugated double bond, which shifts its position, and then the other conjugate bond will make an attack on the carbon, and the plus charge that this double bond opens up and the plus charge on the nitrogen neutralizes. All right. Now the I that was present with this moiety will attack the Si, and Si will be cleaved away, generating the ketone. In the next step, we have been given methyl iodide. So we can think that the NMe2 is undergoing Hofmann exhaustive methylation. Okay. And so if this is the alpha position, this is the beta position. Now, if you're using a base, we can think of a Hofmann elimination reaction taking place over here, giving you the least substituted double bond over here. That is the exocyclic double bond. And obviously, our answer over here is going to be 3. All right. So let's go for the next question, and which is the last one over here now. The major product formed in the following reaction we have to find. It is basically CP2Ti2Me2, which is the Petas's stable reagent used for the olefination or creating double bond from esters or amides. And selectively, as you can see, we have been given a cyclic amide, that is a lactam. There is a ester group attached to the N, and also there is another ester group over here. Now, in other conditions, okay, normally we have expected the ester group to be olefinated, okay, but this is a special reaction or an exception to the above observations in Petas's stable reagent, where esters or ketones can be olefinated, or we can say it is methylated. Okay, the carbonyl groups can be methylated. So what happens over here is that this titanium that is there joined to methyl and to cyclopentadienyl, okay, under heating conditions in a toluene or benzene, CH4 is given away. CH4 is given away, and a Ti C double bond Ti double bond CH2 is formed. Okay. Under this condition, whenever we have the N group attached to electron withdrawing groups, okay, as I mentioned over here, that this case was observed when A.R. Howell and co-work successfully converted amide and range of substituted amides to the corresponding 2-methylene acetines. And this happens whenever we have an electron withdrawing group. This is the electron withdrawing group attached to N. So because this is there, so selectively only this particular C double bond O will be converted to CH2. Okay, so how the reaction happens? This is going through a 4-member transition state. Again, very similar to what happens in a Wittig reaction, isn't it? So the CP2TiO will be cleaved off from that 4-member transition state, and that would subsequently lead to the formation of a CH2 olefin bond. And looking at all the options, we can see here it is intact, here it is intact, here also it is intact. So here we are having the conversion of C double bond O to CH2. Hence, this is our answer. I hope that clarifies all the questions that we had in section C regarding organic chemistry. The next videos will be on inorganic chemistry, section C, followed up by the 2020 November 26th paper. Okay, so I hope you're liking the videos, and keep visiting to Saraswat classes. Thank you for listening. Have a great day.